Hello, in this video, we are going to see how to create um, dynamic int arrays. And in the next video, we'll see how to create dynamic char arrays. You know how to do dynamic int array using the new, which you've seen in the previous sections. What we're going to see here is how to create two-dimensional int arrays, a pointer to a pointer. Okay, so pointer to a pointer is usually used to, like it says, facilitate dynamically allocated multi-dimensional arrays. Okay, so we're going to start with this 2D array. So what we are really looking at is trying to see how to use this in star star PTR. Okay, so first of all, if you look here, make sure you go to this section and take a look at the static two-dimensional arrays. This is a two-dimensional array, right? Make sure you know how to work with static, meaning automatic, not dynamic two-dimensional arrays that get created. So all we are going to do is see how to create these pointers to each row. Okay, so each one of these, notice, can be a pointer, and that's what we're going to see how to do. So let's see how to do this on paper so we can get a pictorial representation before we actually look at the code. We need to know we need to visualize what it is that we are trying to create. Okay, so what we're really trying to do, okay, this part we know how to do. In star PTR, this is how you create your pointer and make it point. This is a dynamic array, right? You have this pointer and you make it point to, you dynamically allocate memory for an array of 10 integers, and that's what this is. So PTR is now pointing to this array that you just created. And you know, if you need to delete it, you would do delete square bracket PTR. We'll make sure we deallocate this memory, and this is broken, and this is all gone. Okay, all right. Now, int star star PTR is used to depict something like this, a two-dimensional array. Notice this is very similar to that two-dimensional array that we saw. So how do you use this and how do you allocate memory? So int pointer to a pointer, that's really what it is. So this is my primary pointer PTR. The first step is to take this PTR and allocate memory for this row of pointers, this guy here. New int star says an array of pointers to an int. So that first creates this step. Okay, all this stuff is not there. All of this stuff is not there yet. We only create this. In other words, we create this, a row of 5 pointers. 0, 1, 2, sorry, this should be just 4, not 5, because we start at 0, asterisk, 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 and so on. So we have created PTR, we had made PTR point to this row of pointers. That's all this does. Then what you need to do in order to do all this stuff, you're going to go through a for loop for I equals 0, I less than this 5 happens to be the same as that number of rows, I plus plus. PTR of I, which is this guy, each pointer now gets memory allocated. Each pointer gets memory allocated to whatever you want. And in this case, I'm creating memory for 10 elements, 10 integers, because anyway, they're all going to be pointing to integers, right? So PTR of I equals new int square bracket 10 says, take this one and allocate memory for 10 integers. And then the next one, and so on and so forth. And they're all allocated memory for 10 integers. Once you have that, then it's a regular two-dimensional array. Then you can fill it however you want. So let's now take a look at the code now that we have an understanding of what we are trying to do. Okay, this code here, I'm going to show you this code in Python Tutor. Okay, let's take a look at the code first. I have two functions that take this two-dimensional array, rows and columns. One fills it, one prints it. Okay, so rows and columns are variables because this is a dynamic array. It's not a static array, so I can have variables. Int star star PTR is a pointer to an int. At the end of the day, they're all going to point to ints. So the first thing we do is allocate memory for a row of pointers. Rows happens to be 5, so 5 pointers, an array of 5 pointers to an int. Then we go through the for loop, a regular for loop. It's just a counter, right? and take each one of those pointers and allocate memory for 4 numbers. Each array can hold 4 numbers. That's what that's saying. Okay, so I have this code on Python Tutor. Let's take a look at Python Tutor and step through this code. It makes a lot more sense when you step through this code. So go visualize execution. I already put it in Python Tutor. It's all ready. So if you look here, we're going to start at the top. I reduced my number of rows and columns so it's easier to step through it. So you step through this code. Rows, columns, and PTR, keep an eye here. Rows is 2, columns is 4. Rows is the number of pointers. Columns is the number of numbers for each array. So 2 rows, 4 numbers each. There is pointers. Allocates memory for 2 pointers. That's what we said. I equals 0, I less than, sorry, here. PTR equals new int. How many rows of pointers do I need? I need 2 pointers. And then I'm going to go through this for loop, and each one is going to get allocated memory for 4 numbers. Watch, there is that one, and there's that one. So if I had more of these, each one would be allocated how many ever numbers you wanted, in this case 4. Okay, so memory has been allocated. Now I am going to send it as a pointer. Here's an important thing. Notice this pointer is getting sent from main to the function, and it's going to get filled. It's a pointer. So it is going to go in and watch what happens when we go into the function. The address from here gets copied in here. So we are looking at that same array in main. Okay, it's not copying anything. It's just copying the address from there to the function. And so this is the same address as this, and we are looking at the same memory location. So now I go through my for loop. It's just a regular for loop, and I put some values in it. I'm taking the index and multiplying it by 3, and so they all initially will be 0 because I is 0. So notice my array is getting filled, 0. Keep an eye here as the array is getting filled, 0. Then the next list gets filled with I becomes 1, which is this pointer pointing to this. So now everything is going to become 3. Just some simple random math that puts some values into my array. Now, when we leave the function, guess what? The array is all filled, and we go back, and we are done. The array has some values, and the print will print it. Okay? So it prints it, and you can see the output box here. So that's how you do a pointer to a pointer. It's really nothing but a 2-dimensional array. You start out by creating this row of pointers first, and then once you've created the row of pointers, take each one and allocate memory. Okay, here's the next important thing. Once it's all done, okay, let's go through and print it. Once it's all done, we come back to main, and how do you now delete this PTR? It's important to not just do delete PTR like this. Okay, you must go through a for loop. I put this in here to show you what not to do. So really what's going to happen if you just do this right now is it's going to delete this array, but all of this memory is going to be there. It's not going to be deallocated, and it's going to be memory leak. Okay, so you don't want that. What you really want to do here is, this is a bad idea, don't do this. Go through the for loop, delete each row first, delete each one, set it to null, and then delete your PTR, which was the original PTR. So if you go through this one more time, and we can go through this really quickly because we know exactly what we are looking at. We create the row, then we create each one of them, then we fill it. There we go, it's done. Then we go print 4 more numbers. Okay, printing is done, and we go back to main, go through the for loop. For I equals 0, I take each one of them first, deallocate these. Notice we are going to go through each one. That means that gets deallocated, and this says there's nothing there, but you want to make sure you point it to null. It's very important. Set it to null. Next, we deallocate this guy, and then we set that to null. Then you can deallocate both of these and set it to null. Very important to do that. Now you can take the same code and try it on the Unix server on GDB and watch the address and see what you get. And you will see that some of the address as we go to the functions are very similar. So in the next video, we'll take a look at exactly the same thing, but with C strings.